Good afternoon. In last lecture, I have discussed the laminar airflow and the different sources of contamination in aseptic area, and started the methods of prevention. Yes, in last lecture, I have discussed the laminar airflow and the different sources of contamination in aseptic area. Today, we will see the next one, that is methods of prevention of contamination in aseptic area. Actually, I already started this point. Is first personnel, then second facility design, then third access to areas, then cleaning and disinfection and utilities. Then the personnel and facility design I will discuss in last lecture. We will continue the same point, that is third, that is access to areas. The entry of authorized person should be prevented in area of production, then area of packaging, and the area of use, that is area of quality control. The entry of unauthorized person should be prevented in area of production, in area of packaging, and area of quality control. Then the personal access must only be made via the changing room. Then next, the materials access must be via specified routes, generally via the airlocks. Then next, that is air building requirements. In building requirements, the interior surfaces, for example floor, walls, ceilings, it should be smooth. In building requirement, interior surfaces, for example floors, walls, and ceiling, it should be smooth and free from cracks, and should be permit easy and effective cleaning. Then the windows and the viewing panels should be non-opening. The windows and viewing panels, it should be non-opening, flush with the all panels, and properly sealed to prevent the collection of dust and microbial materials. Then pipe work, ventilation, and light point, it should be designed to avoid the pipe work, ventilation, and light points should be designed to avoid the creation of recesses which are difficult to clean. Then the sinks within the production area, it should be made up of stainless steel. The sinks within the production area, it should be made up of stainless steel. Then next, that is cleaning and disinfection. The area must be regularly cleaned and where necessary disinfected. Then cleaning and disinfection, the area must be regularly cleaned and where the necessary disinfected. Then contact time, application, temperature, mechanical action, and the chemistry of the cleaning agent should the contact time, then application, temperature, and the mechanical action, and the chemistry of cleaning agents, it should all be considered during the design of cleaning process. Then next, the material used for cleaning, it should not come in direct contact with the product. Third one, that is the material used for cleaning, it should not come in direct contact with the product. Then the validation of cleaning practices must be carried out to provide evidence that the process is effective in controlling the microbial contamination. Next, that is utilities. Then in utilities, the water used in manufacturing of pharmaceutical products should be suitable for intended use. The water used in the manufacturing of pharmaceutical products should be suitable for intended use. Wherever the possible, it should be a pharmaceutical grade, and microbiologically it is controlled and monitored. Then steam used for cleaning as well as sanitization of product, tools, and the equipments supply for autoclaves and humidification must be clean and free of additives. So this is all about the methods of prevention of contamination in aseptic area. So next point about syllabus, that is classification of clean area. The type of clean room garments used should reflect the clean room and the product specifications. The type of clean room garments used should reflect the clean room and product specifications. Low level clean rooms may only require special shoes having the completely smooth soles that do not track in the dust or dirt. However, shoe bottoms must not create a sleeping hazard since safety and always take a precedence. Then the clean room suit is usually required for entering a clean room. Then class 10,000 clean rooms may use simple smokes, head covers and booties. Then for class 10 clean room, careful gowning wearing procedure with zip cover all boots, gloves and complete respirator enclosure are required. Then proper clean room design encompasses the entire air distribution system including provisions for adequate then downstream and air returns. So downstream air returns. Then in vertical flow room, this means the use of low or air return around the perimeter of the zone. Then in, in case of in vertical flow rooms, this means the use of low air returns around the perimeter of the zone. Then next, in horizontal flow applications, it requires the use of air return at the downstream boundary of the process. The use of ceiling mounted air return in contradictory to proper clean room system design. Here we can see the clean room and their properties. First, class 10,000. As per ISO, it is class 7 having property 10,000 or less particle of 0.5 micrometer and larger size exist in a given cubic foot of air. Then next, clean room class 1000, that is ISO class 6. Then having in properties 10,000 or less particles of 0.5 micrometer, 0.5 micron and larger size exist in a given cubic foot of air. Then class 100, that is ISO class 5, the 100 or less particles of 0.5 micron and larger size exist in a given cubic foot of air. The next, here we can see the grade at rest and in operation as well as the clean room standards. Next, we will see the next point of our syllabus, that is microbiological assays. The inhibition of growth under standardized conditions. It may be utilized for demonstrating the therapeutic efficacy of antibiotic agent. The inhibition of growth under standardized conditions may be utilized for demonstrating the therapeutic efficacy of antibiotics. Any suitable change in the antibiotic molecule which may not be detected by chemical methods will be revealed by change in the antimicrobial activity, and hence the microbiological assays are very useful for resolving the doubts regarding the possible change in potency of antibiotic and their preparations. I am repeating here. The microbiological assays are very useful for what? The resolving doubts regarding possible change in the potency of antibiotic and their preparations. We'll see the principle of this microbiological assay. In microbiological assay is based upon the comparison of inhibition of growth of microorganism by measured concentration of the antibiotics to be examined with that produced by known concentration of a standard preparation of the antibiotic having the known activity. There are two generally basic methods that are used for microbiological assay. First method, that is the cylinder plate method. and second, that is turbidimetric method. This cylindrical plate method, this method is also called as what? This method is also called as cup plate method. In turbidity and the turbidimetric method, this method is also called as tube assay method. First, we will see the preparation of media. The media required for the preparation of test microorganism are made from the ingredients. In case of preparation of media, the media required for the preparation of test microorganism are made from ingredient. Then second thing, the minor modifications of the individual ingredients may be made or reconstituted. The minor modifications of the individual ingredients, it may be made or reconstituted. Then dehydrated media may be used. The dehydrated media may be used provided the resulting media have equal or better growth promoting the properties and give a similar standard curve response. Then dissolve the ingredient in sufficient water to produce 1000 ml and add sufficient 1 molar sodium hydroxide or the 1 molar hydrochloric acid as required, so that after sterilization the pH is between 6.5 to 7.5. Keep in mind, so what is pH? That is 6.5 to 7.5. Then the preparation of buffer solution. The buffer solution is prepared by dissolving the following quantity of dipotassium phosphate and the potassium dihydrogen phosphate in sufficient quantity of water in order to produce 1000 ml and adjust the pH with 8 molar phosphoric acid or the 10 molar potassium hydroxide. These are the concentration. The dipotassium hydrogen phosphate, that is K2HPO4, and the potassium dihydrogen phosphate KS2PO4. The pH adjusted for the sterilization. First, dipotassium hydrogen phosphate, that is K2PH4, it is 2 gram. Then KS2PO4, it is 8 gram, and pH it is 6.0 plus or minus 0.21. Then K2HPO4, it is 16.73 gram. Then KS2PO4, it is 0.532 gram and having the pH adjusted after sterilization to 8.0 plus or minus 0.1. Then third, having no K2HPO4, only the potassium dihydrogen phosphate, that is KS2PO4, having the quantity 13.61 gram and pH it is adjusted, that is 4.5 plus or minus 0.1. Then dipotassium hydrogen phosphate 20 gram, then potassium dihydrogen phosphate 80 gram, and pH it is 6.0 plus or minus 0.1. Then dipotassium hydrogen phosphate, it is 35 gram, no use of potassium dihydrogen phosphate, and the pH is adjusted after sterilization, it is 10.5 gram plus or minus 0.1. Then potassium hydrogen phosphate, it is 13.6 gram, and then potassium dihydrogen phosphate 4 gram, and pH is adjusted to the or 7.02 plus or minus 0.2. I will stop here. Next point we will see in next lecture.